So now we are looking at a case in which we are finding the voltage as the charge is moving perpendicular to the electric field strength between the two parallel plates with an initial velocity, in this case 5.60 times 10 to the power of 5, and it is entering right in the mid distance between the two plates that are apart from each other at 8.62 times 10 to the power of -2 meters. So first, let's discuss what is the path that the alpha particle is doing in this case. Since alpha particle is positively charged and it is barely passing the plate, the path that the alpha particle will do will be something like this. So it is barely passing the negative plate. It is going toward the negative plate because the charge alpha particle is positively charged. Again, this is a projectile motion. So we treat it in the same way as we treat the projectile motion on Physics 20, and which we said that is a combination of two, horizontal and vertical motion. In the horizontal motion, we have a uniform motion. And on the vertical motion, on the vertical direction, we have a non-uniform motion. In your formula sheet, you have the uniform motion as principal 0 and the non-uniform motion as principal 1. So principal 0 and principal 1. There are cases, especially on the diploma or unit test, you will most likely see this, where you are asked to find which principle did you use first and which principle did you use second. This is why I always push you to write the word uniform and non-uniform so that it is easy for you to refer to which principle did you use first. Having a uniform motion means that acceleration is equal to 0. Having a non-uniform motion means that you have an acceleration. And based on the second law of Newton, acceleration will be force net over mass. However, since force net, mass of alpha, since force of gravity is way smaller than electric force, so we can say that force net is almost equal to the electric force for what we are doing here in high school. So this will be electric force. Now, since we are between the two parallel plates, where electric force is equal to the electric field strength times the charge, and we have the charge of alpha particle over the mass of alpha particle. And now, between the two parallel plates, the electric field strength is uniform, and it is equal to the ratio between the change of voltage and the distance between the two parallel plates times charge of alpha particles in our case, mass of alpha particle. Now, on this relationship, we go step by step so that we see if the force is given, then we replace it, stop it here. If the electric field is given, then we stop it here. But usually, and especially in this case, you have to go all the way up to the end. So now, on this relationship, the change of voltage is something that we don't know, but we know everything else because the distance between the two plates is given, and the charge and the mass of alpha particle is part of your constants in the data booklet. So let's figure out this relationship as a function of the voltage. So we will have a number times the delta V. This will help us for the next steps so that we always are focusing to, oh, this is the unknown. So let's figure out now what is acceleration as a function of delta V. I will do this on the side so that you have the calculations or those information that we are seeing. So now we have acceleration is equal to delta V over delta D times charge of alpha particle over mass of alpha particle. We don't know what delta V is, so we'll leave it as the variable. And then we know that the distance between the two parallel plates is 8.62 times 10 to the power of -2. The charge of alpha particle in your data booklet is saying that is positive 2e, which means that is a positive charge, and the magnitude of it is 2 times elementary charge, and 2 times elementary charge means 2 times 1.60 times 10 to the power of -19 over the mass of alpha particle in your data booklet is given as 6.65 times 10 to the power of -27 kilograms. So when you enter this information in your calculator, you should have something like divide by 6.65 times 10 to the power of -27. 5.58 times 10 to the power of 8 times delta V. So we take this relationship and then we plot it, have this here as the information about our acceleration. So acceleration will have now a function of the voltage, which is 5.58 times 10 to the power of 8 times delta V. Okay, so this will help us to see better in terms of math what is the variable that we are looking for and which equation do we have to use first. So let's move to the other quantities like velocity and displacement. So velocity in the horizontal will be equal to the initial velocity, which is 5.60 times 10 to the power of 5, I think it is. Yeah, times to the power of 5 meters per second. And the vertical velocity, since the initial velocity component on the vertical direction is 0, will be whatever is acceleration times time. Now for acceleration, we have a function times 10 to the power of 8 times delta V. This is just the acceleration times time. And then the last quantity is the displacement. So x will be 5.60 times 10 to the power of 5 times time. And y will be 1/2 times 5.58 times 10 to the power of 8 times delta V. That is the acceleration, this expression here, times time squared. Don't forget to square it. It's a very common mistake that students do. Okay, so let's take a look now to the sign of the acceleration. Since the object is moving in the negative direction, then the acceleration is negative. In the negative direction of the positive vertical. So this will be negative and negative. You can make this discussion either now when you see, or at the very end, or make the judgment of it saying that the time cannot be negative. Okay, so now let's add the hidden information that is here in the question. So we have the plates are, let's say the plates are 15. I forgot to enter this information. So let's say that the plates are 15 centimeters wide. And let's add now the information. So from the horizontal, which is x is equal to 5.60 times 10 to the power of 5 times t, we have that the alpha particle is moving 15 centimeters. How do we know this? Because it is barely passing the plate. Okay, so now x is positive 15 centimeters, which is the same as saying 15 times 10 to the power of negative 2 meters. And from the relationship that we have here, this is equals to 5.60 times 10 to the power of 5 times time. And this is equation 1 that is coming from the horizontal, which is the uniform motion. Now, from the vertical, we have that the object is moving, is entering at the mid distance between the two plates, which means that the object in the vertical direction is moving this much, which is half of the distance between the two plates, but it is in the negative direction. So this will be negative 1/2 times delta D, which is 8.62 times 10 to the power 8.62 times 10 to the power of negative 2. And now from the relationship that we found, it is equal to negative 1/2 times 5.58 times 10 to the power of 8 times delta V times delta T squared. And this is equation 2 that is coming from the vertical, which is the non-uniform motion. So now we have two equations. Again, we will do the same thing. I have two equations. Equation 1, which is coming from the horizontal or principle 0, and equation 2 that is coming from the vertical or principle 1 in your formula sheet. So which equation are we using first? We are starting to work with equation 1. Because this equation has one variable on it. So let's solve for t, which will be 15 times 10 to the power of negative 2 over 5.60 times 10 to the power of 5. And then from here we find that time is equal to 8.40 times 10 to the power of 4. Sorry, no, something is wrong in my calculations. Yeah, something was, instead of multiplying, I had, instead of dividing, I had multiplying. So the time is 2.68 times 10 to the power of negative 7 seconds. Now that we know what time is, we can use equation 2. Second, we use equation 2, which is dealing with the non-uniform motion. So we'll have negative 1/2 times 8.62 times 10 to the power of negative 2 is equal to negative 1/2 times 5.58 times 10 to the power of 8 times delta V times T squared, which is 2.68 times 10 to the power of negative 7, the whole thing to the power of 2. Let's find now what is delta V. So negative and negative will cancel out. So will be 1/2 is irrelevant, it's both on the same equation. So we can go 8.62 times 10 to the power of negative 2 divided by, open brackets, 5.58 times 10 to the power of 8 times, open brackets again, 2.68 times 10 to the power of negative 7, the whole thing to the power of 2. And this will be 2.15 times 10 to the power of 3 volts. And if they are asking you to record this into A dot BC times 10 to the power of D voltage, And what you will record is only the digits 1, 2, 1, 5, and 3. I hope that this makes sense. You can do now practice on your own with the same logic and the same procedure, where you are changing the particle, changing the width, and changing the width of the plates, and then changing even where the particle is entering.